Okay, so continuing, looking at case number 3. This problem asks us to consider a true SSD technique where the isocenter is on the patient's skin. And so what I want you to understand is this field size that is produced by the collimator setting at 15 by 15 is defined at isocenter. As a matter of fact, whenever you see a field size setting on the treatment console, or you see it in a chart, what the reference is the field size dimensions at isocenter and isocenter only. Because the beam is divergent, the field size changes as you come away from the source. So when we're at isocenter, if the collimator is set 15 by 15, the 15 by 15 is here. At any points closer to the source, this size is smaller. As you can see, the space between these two lines gets smaller and smaller. As you get away from the source, the space between these two lines or the beam edge get larger. So the actual field size at depth in this situation is larger than 15 by 15. Field size and distance are directly related. As the distance increases from the source, the field size increases. The other important thing to remember is field size is defined at isocenter only. So wherever the isocenter is, that's where the field size that's expressed by X by Y is defined. Any other places away from isocenter, this field area would not be the same. It'd be something different. Smaller here, larger here, and even larger back here. So in an SAD technique, let's say if we were treating this patient using an SAD technique, that would mean that the isocenter would be inside the patient. And if the field size setting is 15 by 15, then the field size is 15 by 15 here, because that's where isocenter is. On the patient's skin, the field size would measure smaller. On the patient's posterior surface, if we wanted to know what it was, the field size would measure larger. So in the case that you might get a question that asks about what the field size might be at a point away from isocenter, you could use a direct proportion. The field size at isocenter, which is 80 cm, isocenter is 80 cm from the source. In both situations, isocenter is constant. For cobalt, it's 80 cm from the source. For the linear accelerator, it's 100 cm from the source. So the field size is 15. I'm just going to take one dimension. At a distance of 80 cm from the source, I could calculate the field size at any distance from the source. If I wanted to know where we were, what the field size was at the patient's skin, I'd need to know the distance from the skin to the source. In this situation, since the depth of interest or the prescription point is 5 cm, that's in the question, then this segment, or the distance from the source to the patient's skin, is 80 minus 5. This would be 75 cm SSD. So I want to know the field size at 75 cm from the source. I could use a direct proportion. I could also calculate the size of the field size at the posterior of the patient if I knew what the entire separation of the patient were. So if the entire separation of the patient were, say, 16, and I know that this segment is 5, this distance from here to there would have to be 11. I know what the field size is at 80 cm from the source. I need to know the distance of this segment. So this segment would be 80 cm plus 11 cm. That would be 91 cm. Set up the same direct proportion. 15 at 80 cm. What is the field size? At 80 plus 11, that's 91 centimeters from the source. Okay, let me know if you have any more questions. I hope that clears up last week's assignment. All right, bye.